Okay, so in section 3.6, our goal is to find zeros of a polynomial function. Now, we've done things like this in the past. We've had things like, x squared plus 3x plus 2 equals 0, and we had to solve that, right? So we've done it with quadratic equations, and we had different methods. You could factor, use a quadratic formula. Sometimes we had higher degree equations, but they were always factorable. Now we're going to have equations of a higher degree than 2, and they may not factor, okay? And so we need other techniques. This section has a lot of theorems. I'm just going to warn you. Some of them are easy to grasp and easy to use, but there's a bunch of them. So you might want to get like a little note card or something to write down the theorems, and I'll try to point out the ones that I think will help you the most. Okay, so here's a review of the division algorithm, and it says if you've got some function, you can divide it by another function and get a quotient and a remainder. So this, well, I don't want to start with that. Okay, so when we're dividing, we have a divisor. And if we multiply it times the quotient, and then add the remainder, we get the dividend. Okay, that's what the division algorithm says. Okay, now suppose the fact that the divisor is a linear factor. So if the divisor is linear, then it's going to look like x minus some number. And they use k in the book, so I'll use k. X minus k. That would be a linear factor, okay? So we're going to treat this as the divisor then in our division algorithm. Okay, so let me find the division algorithm. So if that's the divisor, okay, then we get f of x equals x minus k times q of x, whatever, the quotient is, plus some remainder. Now, notice that I'm writing the remainder as r. That's because this is going to be a constant. Okay? So it's because you're dividing by a linear factor. So the remainder has to be a lower degree than what you're dividing by. And if you have a linear factor, then the only thing lower is going to be a constant. Okay, so you can think about that for a little bit if you want to. Okay, now let's say we want to evaluate this function at k. Well, then we would get this. We would get k minus k times q of x, or I guess I should say q of k. Let me put a little k in there. It doesn't matter in a minute, but plus that remainder, that constant. Well, what's k minus k? 0. So that's just all going to be 0 there, 0 times q of k, and so we just get r. So what we're saying is if you want to evaluate a function at some k value, you can do it by dividing by the linear factor x minus k, and then it's going to equal that remainder. That is the theory, okay? So we have this theorem, it's called the remainder theorem, and it's a good one. It's a good one to know. And it says just what I was trying to explain to you. If a polynomial is divided by x minus k, then the remainder equals f of k. So let's say you have some big polynomial. I don't know, x to the 5th plus 3x cubed minus 2x squared plus 7x minus 10. And you want to evaluate that. You want to find what, let's say this is f of x. And say you want to evaluate it at f of I don't know, -2. Well, our old way of doing it might be get a calculator out, figure out all those terms, and figure it out that way, or do it by hand. That would take a while. But now what we can do is we can divide by a linear factor. So make the linear factor x minus a -2. That would be your k then, okay? And then you can just use synthetic division. -2, how many times does that go into 1, 0, 3, -2, 7, -10. So I'd have to have 6 numbers because my degree is 5. I just made this polynomial up, so I don't know if it's any good. But I would divide synthetically. I wouldn't do the long division, okay? And that's the idea here, that we can evaluate this polynomial pretty quickly with the synthetic division. Okay. So I started this problem. I'll go ahead and finish it. 1, -2, -2, 4, 7. Hopefully it won't get too crazy in the numbers. -14. So let's see. Yeah, -14. -16. So that's going to be 32, 39. What's negative? Let's see, -78. I think I'm getting -88. So in other words, if I were to find f of -2, and I plugged that all in, -2 to the 5th, plus 3 times -2 cubed, minus 2 times -2 squared, plus 7 times -2, minus 10, and I did all that work, I should get -88, if my math's right. I think I did okay. Like I said, I just made this problem up. One thing I wanted to talk about, though, is why is there a 0 there? It's because there's no x to the 4th term, okay? So we get to use our synthetic division. Anyway, you can see that it was much easier to do the synthetic division to get that number, -88, than to go through that whole process of trying to multiply everything out by plugging in the value for x. Okay. So that is called the remainder theorem. And I'm going to show you another example in the next video.